Okay, so we're going to consider the following theorem, and that is that let A be the set of all sequences whose elements are the digits 0, 1. Then the set A is uncountable. So how can we prove this? Well, let us consider a countable subset E of A. So consider some subset, some countable subset then obviously by the definition of A, which is the set of all sequences whose elements are 0 and 1, then obviously the elements of E are sequences which involve the digits 0 or 1. Okay, so we can obviously enumerate the elements of E. Since E is countable, we can enumerate them as S1, S2, S3, so on. So we can say then E consists of S1, S2, S3, and so on, okay? Where these are sequences. Now, we're going to construct some sequence that does not actually belong to the set E. And we're going to construct this sequence by taking the entries of each of these sequences. So we're going to say if the nth digit, okay, in Sn is 1, then define, okay, the nth digit of S as being 0. As being 0, okay, and vice versa. So that is if the nth digit of Sn is also 0, then we're going to define the nth digit of our sequence S, our newly constructed sequence S, as then being 1. Now, clearly, the sequence S differs from each sequence Sn in E by at least one position. By the way we have constructed S, that is, obviously, because if I take the nth element of S of my sequence S, I know that differs from nth sequence that I have, or rather any nth sequence that I take from E, I will find that it differs from from my newly constructed S in that nth position of the sequence. So what does that mean? That obviously means that S doesn't belong to the set E. So S is not in E, which obviously implies that E must be a proper subset of A. Okay? So E is a proper subset of A. Okay? And that is true for any countable set E that I take. I will find that it can't be a proper subset of this A. So what does that actually now mean? So obviously A must be uncountable, because if A were actually countable, then one such E in which I could obviously take, because E is a countable subset of A, well, I could just take E as being the set A itself. But in that case, I would have A as being a proper subset of itself, which is obviously absurd. So the implication of this is obviously that thus A is uncountable. Okay? As every countable subset of A is a proper subset.